excellence is intentional, founded by surgical means. Alright, so let's go. Scalar and vector, scalar and vector quantities. Are you with me? So here we'll be looking at the introduction to scalar and vector quantities, their examples. If you are planning not to watch this video to the end, you are wrong, because I would actually be sharing a lot of secrets, a lot of mnemonics for you to code it in such a way that you would never forget again. Then we go into vector resolution. So if you know this video, it's too long for you to comprehend at once, just watch. You can watch a little and then go and grab your popcorn, grab a little rest, and after that you come again, you come back again, because you should not miss any moment, because every moment here is gold. Now, alright, so after introduction, after the examples, we'll go into the concepts behind vector resolution, because if you don't understand this and jump into past questions, trust me, you would find it very difficult. So now you should calm your nerves, understand key things. Let's go into it. Alright, so now scalar is just very simple thing they taught you guys in SS1, and they said they are quantities. Scalar quantities are quantities that has what only magnitude. Are you with me? Magnitude, but no direction. So it's only magnitude they have, and magnitude means what? Size. Are you with me? Size. So like, let's use another word, something like value. So scalar quantity is that quantity that has only magnitude. It has no what? Direction. Yeah. So coming to vector now, vector is having both magnitude and direction. Are you with me? So now magnitude, alright, means size. Are you with me? Means size or value. For example, when they are talking about the physical quantity of mass. Yeah, mass is a physical quantity, alright. So now mass is actually a scalar quantity. Why? Because we only know the value. Let me for example, this is you now, and it was recorded that you have 50 kilogram mass. Now, for us to know that you have mass, what we knew is that is 50. Yeah, what we knew was 50 kilogram. We did not know your direction or where you are going to, but we know your value, we know your worth. So because of this worth, because of this worth, we just call you scalar. Are you with me? We just call you scalar. We will not go ahead and say we know you are a vector quantity, because we don't know your direction. Are you with me? Now, here the magnitude, here this is the value of magnitude. So magnitude means value. Are you with me? Like, we can only know your value, we can only know your worth. That's what magnitude is saying. Now, when you are talking about vector, are you with me? Vector, when you are talking about vector is actually having magnitude. Are you with me? Magnitude and direction. Here we know our value. You get? We know our value, and we still know our direction. Now, our direction here will just be, the direction is actually coming from this cardinal stuff. Yeah, when you're having this coming here, alright, that this, your north will go up, then your south will come down, then your west will come here, then here. Are you with me? So this thing, these arrows are pointing to somewhere, and that somewhere is our maybe either north or west, so this is our direction. As simple as it is, as you can see, it's actually pointing to a direction. So follow closely, we are going somewhere. So right, 30 degree east. So this is actually, this value here is actually showing you that we have the magnitude, and from what I explained earlier, what is the magnitude here? the value is the magnitude. So here the magnitude is 30, but what is the direction? The direction is telling us about, the east. So our direction here is the east. Can you see that this is a vector quantity? An example of this, I think this should be, your this. Yeah, okay, all right. Now this is a vector quantity. So let's go into the examples quantity. All right, so now here let's look at the examples. So their examples are very simple, and here is a mnemonic I use to code it in, and the mnemonic is, under my, we have Mr. Shades, or let's say Mr. Shade is a VIP cat. When they say Shade is a VIP cat, and then we found out that Shade is a guy, so that means he is a Mr. So Mr. Shade is a VIP cat. Now, this mnemonic, we should be able to talk about them one after the other. Are you with me? So let's talk about them one after the other. Mr. Your Shade, are you with me, is a VIP. Let's just manage this place for the cat. Okay, sorry. Let's come like this. C A C. You should manage. Just manage. You guys are Yakub now. Yakub managed. So let's just manage. Yeah, Mr. Shade is a VIP, cat. So now, if you know this thing, if you master this example, there is no how you will not solve questions under scalar and vector quantities introduction, like the examples, the stuffs. Are you with me? So let's move stuffs. So the end there, you know your mass now, so you don't need to stress. You don't need to stress yourself. Your mass, are you with me? Then your R there is just your ratio. Your ratio here, that's coming from your velocity ratio. Please take notes. Then your S there is your speed. Are you with me? Then you should know for H now, your heat energy, your what? Your heat energy. Are you with me? Then you should know your A now, your area. Then you should know your D now. Your D is not distance. So your D is not displacement. Sorry, not distance. Your D is density. All right. Your density. Then your E is what? Your energy. Are you with me? Energy. Then since you are seeing energy, you should know that work, energy and power, your WEP, WEP. You should know that it's not only energy that will be scalar. So definitely our work and power too would be scalar. So WEP also is an example under scalar quantities. So anywhere you see energy, just know that work and power would follow. So your work, energy and power is also an example under your scalar quantity. Then volume. Yeah, your volume. Sure you get your video will be volume. So these things are simple. Then your I. So from our mass, we know that our inertial mass now. So your inertia, alright. Then your P is simply your prayer now. Sure you get your prayer. Then please don't forget all potentials, be it gravitational potential, be it electric potentials. All potentials are scalar. Take note, because they can be very specific. So anywhere you are seeing something potential, anything potential, even be it its potential, just know that this is actually a scalar quantity. Then your C here is simply your charge. These things are very simple. Your A here, we have area before, then we have altitude. Please take notes. Then we have our temperature. Please, these things are very, very, very simple. Very, very simple. So we have our Mr. Shade is a IP cat. So your M there is mass. And now let's actually jump. You can actually review, you can replay if you don't get. That's why I made a video, so you can check again and again till you get it. Just know that your mass, your ratio, S speed, its energy, your A there is area, your density, energy. Since you are seeing energy, you know that work and power too should be there. Then your volume, all right, your inertia, then your pressure, your potentials, your charge, altitude, and temperature. Are you with me? So now this mass here, since mass is a scalar quantity, you should know that your weight will not be scalar. Your weight would now be vector. So let's just manage this side for vectors. So vectors examples. Vector example. So what are the examples of vector quantity? There is another mnemonic I use to code this in such a way that I would never forget again, which is my VAMD square. Okay, right? V, that's va. Okay, let's write it out first. Let's write it out first. Our VAMD, then FM, my FM radio, FM, then big tail, alright, big tail, FM, big tail phone. Are you with me? VAMD, FM, big tail. Are you with me? So that's how I code this thing in. Now your velocity there would now be your V. Okay, let's write it out first so that we can understand. So your VAMD, let V be here. My A, you get my M, this my VAMD, then my big tail B I G. Please take note of all this one are for my scalar. This ones are for my scalar. Please take note of. Don't go and do mistake. The body is kind of so big, big tail. Are you with me? Big tail. Okay, VAMD. FM should be somewhere here. Sorry, let's clean. I think we should B I G then T E L F M big tail. So let's now look at them one after the other. Very simple. You know your V now. Your V here, please take note under vector V. Your velocity is vector from your VE vector velocity. Take note. Very easy from your VE velocity. Now then your A there would be your acceleration. Are you with me? Then your M would be momentum. Then your D here would be what? Your displacement. Are you with me? Your displacement, because you know that your displacement is actually having direction, and so yeah, vector. Then your force, then your M, still momentum. Then your B would be your buoyancy. You can call it thrust also, or you can call it weight. So weight, don't forget, maybe we should change this to weight. Let's change this one to weight. So under vector, that's where weight is. Please don't forget, weight is the kind of force. So your I here is impulse. Don't forget that under scalar it was inertia. Under scalar it was inertia actually, but under vector it's impulse, right? G here would be your gravitational field. Your grav field, that's your gravitational field. Then your torque, you know that under scalar it was temperature. Where is it? Yeah, temperature. But under vector it's torque. Then we have our electric field. Are you with me? Electric what? Field. Go and look for that of L by yourself. Check for vector let's go into vector resolution. We successfully like explained, you know, your introduction of scalar and vector, their examples and all. So yeah, vector resolution. So let's check for these cases. You know, I mentioned that we'll be checking for these cases. So let's check for these cases. You know, cases of the forces being parallel, the forces being anti-parallel, then the forces being perpendicular, then the forces being acute and obtuse. So this should be our case one. All right. So what's our case one? Our case one is when like two forces are parallel in the same direction. All right. So now, yeah, the case one. I hope you guys are even writing. Are you even writing at all? So case one is when the forces are, you know, parallel. All right, parallel. So when you have two forces, something like, you know, something that is parallel like this, you know, yeah, two forces parallel to each other. Okay, let's call this our F1. Let's call this our F2. All right. So maybe just let's call this one like this one is in 2 Newton. All right, and this one is, let's call it 4 Newton. So what this case is actually telling you is that if two forces are actually parallel to each other, as you can see, that means they would be in the same direction. You can see the direction now, the east direction. How do we know that it's east direction? From your cardinal stuff, like this. So these are north, south, then your west and east. Are you with me? So it's going to this direction. All right, so that's how we would know our direction. And what will be our direction? Our direction would be east, the eastward direction, the east direction. Now if this thing, how are we going to like resolve? We need to resolve these forces into one, and we call that resultant. So if you actually like getting your force as one, we call it, you know, our resultant. So we've looked for our direction now, so it's time for us to look for our resultant. Now resultant is actually coming from the combination of two vector forces. Now if they actually combine, if the thing is parallel, if the forces are parallel to each other, it means they are on the same side. And if they are on the same side, if they are actually on the same side, you have to add. So that's the rule. That's case one for you. That's our case study, that if two forces are parallel to each other, you do what? You do the algebraic sum. You add. Very easy. That's your resultant will be your F1 plus your F2, and you get your resultant. Very easy. I think that's about case one. Let's go to case two. Case two is when they are what? They are being anti-parallel to each other. So let's do for case two. Are you with me? Case two. All right. Case two saying that it's anti-parallel to each other. So now when they are anti-parallel, they are talking about something like this. One is going to this direction, but one will not follow this direction. One will now go and follow another direction, making them opposite. So when I say something is anti-parallel, it means they are opposite to each other. As you can see, one is going like this, another one is going like this. So let's call this our F1. Let's call this our F2. So because they are opposite to each other, they are anti-parallel. They are not parallel. Then what do? How are you actually going to get the resultant, and how are you going to get the direction? So our resultant would come from, you know, combination of the two forces. But yes, since it's anti-parallel, since they are opposite, that means they are not relating, they are not agreeing with each other. And since they are not agreeing with each other, you would subtract. That means you are subtracting your bigger force from your smaller force. That's the case for anti-parallel vectors. So as you can see, they're actually anti-parallel. I mentioned that earlier, like this. Then the direction, how are we going to find the direction? Are you with me? The direction. So here, let's say this force, maybe they give you your F1 as 6 Newton. Now give you your F2 as 12 Newton. So the bigger force between F2 and F1, which one is bigger? F2 is bigger, so that's our direction. As easy. That's how you find your direction under case 2. Are you with me? Under case 2. Now be your direction here is your 12 force Newton. Don't let us put force again, 12 Newton. So alright, that's your direction. That's your direction is going to what? This side. And that direction that is going to this side will be from your north, south, west, and east. So it's pointing west. Are you with me? So the direction is west. That's 12 degree west. Are you with me? Newton, something like that. So that's for case 2. Let's enter case 3. Let's find our way in. Our case 3 is telling us that when two forces are what? Perpendicular to each what other. Are you with me? So when two forces are perpendicular, so you are looking at case 3 now, perpendicular to each other. How do they mean, or how do I mean? So let me draw something. So perpendicular would be something like this, something like this. Then you have your F1 here, you have your F2. Like it's perpendicular to each other, like at right angle. Are you with me? This thing here at a right angle to each other. Now what are you going to do here? I think this is actually established when there are what? Two forces. This is your first force, this is your second force. So if they are what? Perpendicular, like they are at right angle. Like perpendicular means like something like at a right angle to each other. Perpendicular to each other, meaning that this is what they are saying, like they are perpendicular. So meaning that if this side here, if this side from here to here is F1, you have to agree with us by force that your this place 2 is F1. Draw it up. Or this place 2 is what? F1. Are you with me? Your F1. Then if this place is what? F2, like this horizontal part, you must agree with this place 2 that this place 2 is what? Equals to this place, like it's the same to F2. Are you with me? I hope you are getting the simple analogy. Are you with me? Alright. So now what would be your resultant? What would be your resultant? Your resultant is actually going to be drawn from the point of intersection. From the what? From the point of intersection. Where's your point? This is your point of intersection here. So you have to draw it from here like that. So that's actually pointing your what? Your resultant. Now this will now be your F of R, your resultant. Your F, like the one F. We want to make the two F1. So now this section is actually telling you that you can have it like this. You can choose to have it like this. Are you with me? You can choose to have it like this. Then you can also choose to have it like this. You can choose to have it like this. Are you with me? So like drawing it out now, you have something like something like this for this side, or you have something like this. Yeah, the same thing from here. As you can see, I brought this, I brought it out, I brought this, I brought it out again. So are they different? They are not different. They are still the same thing. Let's prove it. This vertical side F1, put it there. Your horizontal side, are you with me? F2. Find horizontal here, put it. Now let's check vertical here. What? F1. Put it. Horizontal here, F2. Alright, put it. That's very simple. Then how will you now find the resultant here? Where's your resultant? Your hypotenuse side. From your SOHCAHTOA. So your hypotenuse side here, your hypotenuse here, IP here, would be your resultant, the value for your resultants. And how are you going to find your hypotenuse? So your hypotenuse, which is your resultants, we actually go and use Pythagoras. Pythagoras what theorem. And what's this theorem saying? It's telling you that your hypotenuse what square is equals to what your opposite square plus your what adjacent square. Please take note. Take note. And how would you know your hypotenuse? Firstly, you know that this is a right angle triangle. Then if this is a right angle triangle, your theta will definitely be here. Then your theta is actually the one that will point out your opposite. So the arrow would come from your theta to here. Then that means this is your opposite. And definitely if this is your opposite and if this is your hypotenuse, then this would definitely be your adjacent. Then you begin to resolve to get your resultant. So that means this is your resultant. Is hypotenuse square is equals to, that's your hypotenuse square is what the resultant, normal. Then your opposite square is your f1, right? That's your f1 square plus what's your adjacent square, f2. That's f2 square, and then you're able to resolve very fast, and that's your resultant. Are you with me? Very easy. So if you do this for this quarter session, so you will get the same answer or you will get the same resultant. Then how are you actually going to get your direction? Direction. Your direction is actually going to be your how am I going to call it now? Your theta. Actually telling you about the direction of how would I call it, like of your angle. Don't forget that you have your angle here. Sorry, let's call it, this would be for this one here, this would be for this one here. Then you have your theta. So this is your theta 1. Are you with me? No, sorry, this will be your theta 1 for this. Then this will be your theta 2. So now this one and this one is our direction. And how do we know? So now the angle that is in between your f1, and your resultant is your direction for theta 1. Then the second direction, which is your theta 2, is now the angle, this angle that is in between your resultant and your f2. Are you with me? So yeah, let's move to case 4. Alright, so don't forget where we are coming from, being perpendicular. Alright, being perpendicular for our case 3. So if this is your f1, I explained already. Please ensure this is just a review, because we need to get our theta. This will be our f2. Then you have to trace the cutout section like you have here. So here will be equal to here. Are you with me? Equal to here. Let's use imaginary line. Let's just imagine. Then here another cutout section which is actually meeting here, is meeting here also. So now, alright, so yeah, and I said that my resultant is actually coming from the point of intersection here to here. So I have sorry, this is not accurate. Just manage for me, manage for me. This is not accurate enough, but manage it for me. So yeah, this will be your what, your f of r. That's your resultant. This will be your theta. This will be your theta 2 for here. This one will be your theta 1 for first one. Then now, so we actually got our resultant from small resolving now from your Pythagoras. Alright, so I don't need to say that again. I've explained before. Now, how do we get theta now? That direction. How are we going to get it? For you have to know that if you want to get for your theta 1, theta 1 will be the angle between your resultant first and f2, right? So your theta 1 will be given as 90 minus theta 2. Theta 1 is equals to your 90 minus theta 2. So now if you do normal mathematics, your theta 2 will now be given as your 90 minus theta 1. You get now. So alright, so now let's go to how do we get for theta from SOHCAHTOA. Yeah, so in calculations you have to know how to get your theta, and your theta would come from your normal your SOHCAHTOA. Then here, how do we get from this? Let's use this cutout section. Yeah, your cutout section. Yeah, so you'd have let's use our tour. We are using our tour. That is your tan is equals to opposite over adjacent. So your T is tan, your O here is opposite, your A here is what? Adjacent. Now what's your opposite? Your opposite. So you check. My opposite is the like the arrow. This angle is telling us like, yeah, this is what I mean. Sorry for talking like that. So from here to here, sha, this is my opposite, sha, that's my F1. You get now my F1 now. So my F1. So my opposite is what? F1. Then what's my adjacent? My adjacent is the one that is just down, sha. So yeah, my adjacent is what? F2. Are you with me? So my tan, what? Theta is equal to F1 over. Then if I want to now get my theta will now be the what? Tan inverse of my F1 over F2. Don't worry, when we begin to solve calculations, you would understand this thing much more better. If you are tired already, you can pause the video and go and rest. Grab your popcorn, grab your pancakes, grab your jollof rice and beans, then grab it and then just come back and continue. So I think that's for case 3. So I think we are good now. Let's go to case 4 now. Case 4 now. Case 4 now, you have to two vectors. When two what vectors are at acute angle to each other. When two vector forces are at acute angle to each other. What's acute? Acute is just telling you that like the angle is actually like less than 90 degree but greater than what? 0 degrees. That's what they're actually talking about. So here we'll be having something like this, something like, are you with me? Something like your hand like this. That's your acute angle. Can you see? Like this. Let's draw it out. So if it is like this, then it will be like this. Can you see it like this? So that's for acute. Just something like this. Please take notes. This thing is very, very simple. We are progressing. Let's say we are advancing small from our normal plus to minus to our perpendicular from Pythagoras. Then here now we are advancing. We are at A level now, advanced level. All right. So yeah, this would be your F1, your first one. This should be your F2. Are you with me? So now I told you, just like I said under perpendicular stuff, like under case 3 where I said if this side is like this, then we can assume that this side too is like that too. So you trace, so you have your direction. Then so if this side is like this, then we would know that this side too should actually close. Are you with me? So you put your direction. So now I think we are good. Then we would now have, so this cutout section will be your F2 now. Since this place is F2, so this is place F2, so this place will be your F2 also, like this section. Then since this horizontal part is F1, your horizontal part which is up to be your F1. Are you with me? Then this is actually bringing our attention to our parallelogram law. Law. So what does this law state? Let me read this for you. You will see it will pop up on your screen. You get parallelogram law. Parallelogram law of vector states that if two vectors are represented in magnitude and direction by the adjacent side of a parallelogram, the diagonal of the parallelogram drawn from the point of intersection of the vectors represents the resultant vector in magnitude and direction. So this is what they are saying here, that if there's two vectors like this vector F1, vector F2, are you with me? Now represented in magnitude and direction, like we know our magnitude. So maybe the value of f1 we know, the value of f2, like, and we know the direction, this arrow, like it's going from here to here, from here to here also. Now they said the diagonal of the parallelogram drawn from the point of intersection. So like from the point of intersection where the two of them intersect here, they said there's a line drawn, and they call this line your resultant from the point of intersection of the vector. Yeah, represent the what? The resultant vector, your f of r. Are you with me? Resultant in magnitude and direction, as you can see. So this is the concept behind your acute angle. Your acute angle. Alright. So let's look at how to get a resultant. Would see that this is actually looking like our quadrilateral, yeah, that is having, from the properties of parallelogram, it says that, opposite sides are equal, and it says another thing that, opposite angles are equal also. Please take note, you have to know that opposite sides are equal, opposite angles are equal. Like if you have angle here as what, your theta here is 30 degree. Let me just write only for this thing, like 30. If you have 30 degree here, so your opposite angle is equal. So where would be your opposite angle? Like from this would be your opposite of this angle, and it would also be 30. So opposite angle are equal. Shey you get? So 30 to 30. Same for here. So if this place is 30, let's do it. This theta, the second theta. Let's put it there also. That means this place will be 30 degree. Then yeah, yes. Then sorry. I think yeah, this side, then this side and this side. Now, what about the parallel side? Then the sides that are parallel, let's take this place for example. This will now be your 180 minus your theta. Are you with me? Your 30 minus 180, that will be the value for this place, and it will be equal to this also. Same thing. Are you with me? I don't need to write it again. So we already know. Are you getting it? Is it making sense to you? Small. Follow closely. Follow what? Follow closely. Your 180 minus theta. So yes, how do we get our resultant here? Actually, we'd actually go and apply one law like that. Let me just use this analogy. So here, then you have this place as A, you have this place as B, now this place as C. To get your C would be your normal stuff. Maybe there's now an angle between them, So what you will now do, how you get your cosine rule formula would be your A plus B. That's A and B. That's A plus B, right? Then you now subtract from 2A to AB. Then just add your cos theta. That will be your value for C. I don't know if you get the scope, or you should if you don't know itself, cram it on your head. You should know this formula normal. So I'm just trying to find a way that it would be fun. So like you have A and B, so just put A plus B like that. A plus, your A plus B, then your 2AB again, 2AB cos theta. So that's cosine rule. So the same is the case of this parallelogram stuff under acute angle here. So that means our resultants, if you draw this cutout section out, like let's deal with this cutout section now. So it now be that, okay, normal, this is my F2 now, like this is my F2, this is my F1, alright, this is my F1, this is my F2, this is my F2 again, this is my F1, alright. So now, how am I going to, and I have my cutout section. So what will be my resultant? That means my resultant will be this, my 2F, that's my F of R will be my F1 squared. You do not remember to add square here, please add. So F1 squared plus your F2 squared plus 2F1 F2, that's minus 2F1 F2, then cos this, that's cos 180 minus theta, and that's how you get your resultant. Very easy. Resultant, please take note. our resultant. So then for our direction, how are we going to find our direction? That's very easy. Many students are finding this one difficult, but it's very easy. Your direction is just is like pointing to your force, like pointing to your force. How do I mean? From here now, this one is pointing to F1. You have your alpha 1. That's your direction 1. So that's for, and it's pointing towards F1. That's your direction now. Then the second direction is actually pointing towards F2. That's your alpha 2. Are you with me? So your alpha 2 is pointing towards F2. Very easy, Jare. Let's go to case 5. Alright, case 5. So case 5 here is talking about, we have done for acute, that's for our case 4. Then case 5 we are doing for obtuse. Now obtuse, what's an obtuse? This is when two vectors are at obtuse angles to each other in the same direction. So now what is obtuse? What do they mean by obtuse? Obtuse is actually your angle, where your angle is, like less than 180 degree, yeah, then but greater than your 90 degree. Are you with me? So that's for obtuse. That's what of an acute is actually, greater than 0 but less than 90. But yes, less than 180 in obtuse. And your obtuse is something like, how would I call it now? An obtuse is actually telling you that it's something like this. Are you with me? Like this? But if it is an acute will be like this. Are you with me? Like this. As you can see here, pam like this is acute, like this. But coming to obtuse now, obtuse now be like this, pam. Let's draw it out. Something like, you get, sorry, it's not resembling what I want. Are you with me? Something like this. So yeah, let's draw it again. It's not like that. Should be like, oh yeah, continue like this. Sorry, like this. Yeah, that's how I did my hand the other time. So this is an obtuse angle. So it's like this. Can you see? Like this. But coming like this, it's becoming acute. Are you with me? It's becoming acute. But like this is your obtuse. So this is obtuse angle that is actually less than 180 degree or greater than 90 degrees. Alright, so let's just go. Alright, so this should be your, let's call this F2. This is your F2 pointing to this direction. This is your what? F1 pointing to this direction. Then from case 4, similar to acute, if this is your F2, then we can actually say this our side 2 is similar. So let's just try to trace it up, just like this. Sorry, let's trace it well. Are you with me? Then that's for your F2, right? Like put it there, F2. Let them know that something like this, Then let them know for F1 too. F1 is actually coming like this. That's your what? F1. Then from parallelogram law, they said the resultants will be drawn from where? Point of intersection. This place. That's where your resultants would be. That's where your F of R would be. So meaning that this place is your F1, you get this place also will be your similar stuff, F1, but your F2 here will be your F2. Are you with me? So now to get your resultant, very easy. Resultant here, your FR, that will be your FR is equals to your F1 squared plus what? F2 squared. That one we said now, that cosine rule now, 2F1 F2 cos, this place I told you 180 minus theta, please don't forget. Then 180 minus theta. When we begin to solve questions, it would make more sense to you. All right, see this obtuse part. JAMB rarely ask questions from here, but it is important for you to like master it if you are a WAEC candidate. So as a WAEC student, know it. WAEC would always bring it for you. Are you with me? But JAMB rarely ask questions, but that does not mean that you should not know it because maybe when someone you are in 100 level you need it. Are you with me? So that's case 5. Now let's go into questions based on these cases, and maybe we'll try to check for one more case, like case 6. And you see this case is very complex, so Jesus, that's where you'd be resolving your vector components, your horizontal components. This part is extra complex, but we will do it. We will do it. Are you with me? So all right, let's go to questions. Let's go to questions. Few questions you get, so that's to reinforce the knowledge. So question 1, it says, so it will pop up there. An object is acted upon by two forces. They said that means force 1 is what, 5 Newton. Alright, then and 12 Newton. 12 Newton. Are you with me? Calculate the resultant of the two forces if the forces are parallel to each other. So we see that the forces are actually parallel to each other. Are you with me? So if the forces are parallel to each other, use the first law, case 1. So case 1 is telling us that the resultant here is your F1 plus F2. That's your 5 plus 12. Both this thing is carrying you Newton. So 5 plus 12, that would be your 17 Newton. Are you with me? So let's go to question 2. We don't need to. So, but suppose they say it's anti-parallel, or they say it's opposite, like the force is opposite to each other. If it's there in the question, then it would be your F2 minus F1, which would give you 12 minus 5. But here they are talking about parallel, so we have to add the algebraic sum you get. So alright, let's go to question 2. It says, okay, that same object that is acted upon by forces F1 and F2, 5 and 12, right? It said calculate the resultant of the two forces if these forces are perpendicular. Like what they mean is that if the forces are what, like if they are perpendicular to each other, something like this. So now if the forces are perpendicular to each other, like perpendicular, all right, and you have your 5n here, so your 12n again. So as you can see, it's like perpendicular, like at right angle to each other. And they say that you should do what, you should calculate the resultant of the two forces. And I think this should be our case 3. Yeah, that's our case 3, where we said that if two forces, two vector are perpendicular to each other, would actually find the resultants would actually come from like the points of intersection here would be our resultant. So that would be our f of r. So for us to like solve for our f of r now, I think the cutout section would be, I'm coming, sorry, let's cut the section out. The cutout section will be like this. Then we now have, sorry, this should not be, this should be at right angle to each other. Are you with me? So if we trace this up, let's do it. I think I don't even need to do all these things because we know them already now. I explained very well on that case, this thing. So the line that is being drawn from the point of intersection here would be our what, our resultants. Our f of what, of r. Are you with me? F of what, of r. So yeah, let's look for this f of r. And I explained that if they are perpendicular to each other, you don't need to stress yourself. You just use your what, just use your Pythagoras, and your Pythagoras theorem, which is your hypotenuse square is equals to your opposite square plus adjacent what, square. Then what is your hypotenuse? This line here, this point of intersection line, or what do they call it, is always your hypotenuse. And if this is your hypotenuse, where is your angle? Your angle is one that would like point towards the direction of opposite. Sure you get. So this would always be your opposite because your angle is showing it actually. Are you with me? Then this line that remains here would now be your adjacent like that. Are you with me? So alright, now what will now be your resultant? So your resultant is your hypotenuse, that's your FR square, which is, what's your opposite square? That's the opposite square is 5. 5 square, your adjacent is 12 plus 12 square. Are you with me? Then F resultant square. 5 square is what? 25. You should press your calculator. 12 square will be 144. So now, yeah, your F will now be, if to cancel out this square, you have to square root what? Both sides. Therefore, we have, so press your calculator. Let's press it. Let's press our calculator. So 25 plus 144 would give 169, right? So the root of 169 should give you 13. Are you with me? 13. 13. So yeah, we would have our value of force as 13 Newton. Are you with me? So yeah, let's go to the third question. The third question says that an object is acted upon by two forces of 5 and 12 Newton. We are still using the same 5 and 12 Newton again. Calculate the resultant of the two forces if the force acts at an angle of 40 degrees to each other. So here, this is an acute angle, an angle that is greater than 0 but less than, your 90 degree. So let's draw a diagram out. So here would have your acute. You know how your acute looks like now? Something like this. All right, are you with me? Something like this. Something like this. Then you're having something like this. You now have an arrow here. You have another arrow here. Then this is your point of intersection, which will be drawn to form a parallelogram. You draw this line here, then another line should come again. So this are direction of the force, and that direction again. Are you with me? Don't mind my drawing, just get the concept. So alright, yeah, they said our force remains 5 and 12. Alright, 5 and 12. Your F1, there will be your F2. And if this place is your F1, you know that this place is similar to this imaginary line here. So that's, this place will be your F1 also. This line also is similar to your imaginary line here. So that means this is also your F2. Are you with me? This is also your F2. So now, they say that force F1 is 5 Newton. 5 Newton, while F2 is 12 Newton. Please, are you confused? Don't be confused, please. Alright, so yeah, they said we should look for the resultants at an angle of 40 degrees. So this is your resultant here, F of R, like breaking them into sections. If you choose to go for this cutout section, fine. If you now choose to go for this cutout section too, fine. Are you with me? If you choose to go for this cutout section too, fine. So alright, let's solve. Let's start solving. So we'll solve for our resultants and we'll solve for our our directions. So don't forget your force, so 40 degrees. And I told you, I think from parallelogram law of force, the 40 here would also be equals to the angle here too, you get the angle here will also be 40 degree here, 40 degree here. But coming here to now become 180 minus theta, which is 180 minus that your theta minus 40. So 180 minus 40, 180 minus 40 will give you what? 140. Yeah, 140 in degrees, which this will be our real temperature. Now, how would you calculate the resultant? You know that I explained under, is that case 4, where I said that the resultant will come from cosine rule, which is your FR be equals to the first force, your F1 squared. Please don't forget, plus your F2 squared minus your 2 f1 of f2, alright, cos theta, and then that cos theta should be 180 minus theta. Please, your theta is in 40, so you should not go and use this 140 and be, don't make mistake, please, don't make mistake. We resolved here, but I was trying to write this one out here again. Don't be confused. The normal theta, let's call it fake theta, it was 40, while our real theta that we would use in this cosine formula would be 140 degrees, and our 140 degree was coming from 180 minus a fake theta. That's 180 minus 40. Are you with me? So alright, so let's continue. So your f of your resultant force will be equals to, what's your f1 now? Your f1 is 5 now. 5 squared plus, what's your f2? 12 was squared minus 2 of 5 of 12 cos 140 degrees. Then your f of r is, here is 25, here is 144 minus. So let's do for this. Let's press our calculator fast. You'll be able to do this now when we are not primary 1 students now. So you press your cos 140. They will not give you the value of 140 in your JAMB, so you should know them. I don't think they even give you something like 140, but sometimes they might be wicked. Are you with me? They might be wicked. They might want to give you something like that, whereby 120. So press your calculator. You should have something like minus 91.92. So don't forget to minus 91.92. And see, this, when you press your calculator, you have something like minus, and it's not the same minus that is here. That's why you should like write it well, put it inside bracket so you will not be confused. So your f resultant, press your calculator. Let's get our answer. 25 plus 144 is what? 25 plus 144, that's 169. 169. Then your minus that is here, you break it down. Another minus again, that's 91.92. So press your calculator again. 169 minus 91.92. 169 minus 92. You should get your answer as 260.92. 260.92. 260.92. Are you with me, Newton? So that would be your answer. Alright, that would be your answer. Ensure you put your square, please. Don't forget your square. So, and then you want to cancel this square out. So you have to square both sides like that. That you cancel it out. So if you are squaring both sides, then your resultant will now become, check, I think 16.15 like that in Newton. 16.15 like that in Newton. Let's do for the direction. How do we find the direction here? How do we find the direction here? The direction is simple. Bring out your cutout section. This is your cutout section. This is your cutout section inside this place. And you might go for this one, but this is what me I want to go for. This place is your F1, right? And your F1 is 5. Then this place is your 40, right? But here we are trying to look for direction. I told you that direction is one that is pointing towards our force. So this one will be our theta, the direction of this one. Are you with me? Then the second direction too. This is the second direction, so point it to the direction of the second force. So that means this place will be our alpha like that. So you get, then this place will be our normal 140. Still remains our normal 140. Are you with me? So alright, let's draw it down so that you can understand this thing better. You have something like this. So your 140, your alpha, your 5 Newton. So and that's that. So alright, from this cutout section now, your F1 5, your normal theta 140. The direction you are looking for is your alpha, and then your f of r, and your f of r is 16.15. 16.15 Now, how do you find direction? Yeah, you use sine rule. Go and master or go and check Lami's theorem. You'd understand how they got sine rule formula. How they got, A over sine A is equals to B over sine B. Should we quickly check it? Or we should just move? Are you with me? Alright, so yeah. So meaning that this one, this one theta, it will point to this place. While this one too, it points to here. Are you with me? That's how we have our 5 over sine alpha is equals to our 16.15 over sine. When these two forces are 125 degrees to each other, it's actually telling you that it's obtuse. So let's do for that case. I think, is it case 5? Yeah, case 5. That was the last case. So we should solve for something obtuse. So, and this is it. So the question, we are progressing on that same question, that if the angle is 125, meaning that it's obtuse, meaning that it's actually greater than 90 but less than 180. Are you with me? So right, let's draw the cutout. How does an obtuse look like? I explained to you earlier. It's like this. Then now have it like this. Then alright, still now have it like this. Are you with me? Then we now have your cutout section, right? Like from your point of intersection. Then this will now be your resultant. Are you with me? To be your resultant, this will be. Are you with me? Well, then yeah, just like this should come here from the point of intersection here. So it will now be this is your f of r, meaning that you have your theta is 125 degree. Are you with me? Which will be same for this place also 125 degree. But for here, these are fake theta, but our real theta here will now be 180 minus 125. So press your calculator. That would be 1 degrees. So our real I want to say temperature. Our real theta is 55. Are you with me? So then you now go to your cosine formula to get your resultant. Can you see that these things are very simple actually? Our fr square, which is my f1 square plus f2 square plus 2f1 f2 cos 180 minus theta, which is 55 sha. So theta. So you guys should be able to solve for this. You guys should solve for this and send your answers to me. Yeah.